We are up to 4 for day 1. Here we go, running out of first trimester, Algebra 2A. So as you can see, we're going to be focusing on adding and subtracting fractions. Now don't you think for a second that they're going to look like this or this, but you got to have the basics down before you can actually tackle something a little more difficult. So here we go. You already know that you need common denominators, okay? Not true if you're multiplying. You just cross-reduce, swoosh, that'd be 1/6. But when you're adding fractions, think of it this way. If I run 2 miles and I run 1 mile, that would be 3 miles. Now, notice what happened. Don't take these little things lightly. I added the numerators, and the common denominators did not change. I did not make this 3/14. That is wrong, wrong, wrong. 3/7. You know that. Now, about these crazy looking ones. Well, don't panic. We're adding fractions. You gotta have common denominators, and lo and behold, we do. Don't add the denominators though. You add the numerators. So we get 3 over x plus 2. Done. Are they all gonna be that easy? No. Are some of them? Yeah. Uh-oh, we don't have common denominators. Now, I know that if I actually went 1/2 plus 1/4, we've been doing this, you could take the 1/2 and just make that 2/4, and now you can add these together, okay? So sometimes you don't need to change both denominators, but that's when you're in the number world. We're in the algebra world, so there's going to be a little change, and you need to pick up on this, okay? And here's the point I'm trying to make. I have 2 different denominators. You can see that our common denominator is going to be 14. How do you get that? All right, a little interruption. Sorry about that. So 2 times 7 gives me my common denominator. What I'm saying is, when you're dealing with numbers, if I use that as a rule all the time, I'd get 8 when that's not necessary. But this rule is going to be necessary for these. That's what I'm trying to say. We're going to multiply these 2 together. It just works. That's why I picked this example. If I multiply these together, I get an 8, which is just creating more work, but you'll still get it done. So that'd be 2 8s and 4 8s. So I get 6 8s, which reduces to 3 4s. So, but keep in mind the rule. Just multiply those 2 together. Boom. So, what do I have to multiply 2 by to get 14? 7. So I got to multiply the top and the bottom by 7. So I get 7/14. I got to multiply this by 2 to get a 14, so I got to multiply that by 2. So there, 7/14 plus 2/14, 9/14. Now, things are going to get a little tricky. Get out the red marker. Here's a number, don't know what it is, because we don't know what x is. Here's another number. It's different than this. So how are we going to find common denominators? We're going to stick with the program. We're going to multiply these 2 together. So my new common denominator is going to be x plus 2 times x plus 3 plus, am I still on the board there? Barely. X plus 2, x plus 3. All right, now we got to do some thinking. So we're going to think backwards a little bit. Remember, if I have a fraction 2/3, I can multiply it. We've done problems like this before by anything that equals 1. We're going to change the way it looks, but we're not going to change its value. You see, that would be 14 over 21. It looks different, but it still equals what it used to be, because anything times 1 is itself. We're going to have to use this here. So the question is, I'm going to give myself some space here. What do I have to multiply the bottom by, this, to get this? X plus 3. Well, if I did that to the bottom, I have to do it to the top. Now what's 1 times x plus 3? That would be just x plus 3. All right. Now, don't get into the world of factor, 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 factor. Don't start thinking cancel out because we're adding. See, it's different than multiplication. Now we're going to do the same thing here. Ask yourself, what do I got to multiply that by to get this? And the answer would be x plus 2. But if I do that to the bottom, I have to do it to the top. And if I distribute, I would just get x plus 2. Don't forget the rule. The denominator doesn't change. The denominator doesn't change. So I know my denominator is going to be x plus 2, x plus 3. What do I do with the stuff in the numerator? Add. So you look for like terms. X plus x is 2x. 3 plus 2 is 5. Now there's a little twist here. When you get to your answer, you got to remember the golden rule from before, factor, 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 factor. But you can't factor this. So in this case, you're done. But there will be problems where you think you're done, but you're not. So I'm giving you a big hint there. Grand finale of the pre-lesson, 4-4 day 1. All right, more stuff. More stuff. More complex looking. But you got to stick with what you know and move forward. So here we go. We got a 2, a 3, and a 7. You know what that means? All three of these are different. So what we're going to do to find our common denominator is essentially multiply all these things together. So that would give us 2 times 3 is 6, 6 times 7 is 42. 42, 42. Now here we go. Ask yourselves piece by piece, what do I have to multiply the 2 by to get 42? That'd be 21. If I multiply that by 21, I gotta multiply that by 21, which is just 21. Now I'm gonna do the same with the 3. 3 times what is 42? That would be 14. But I gotta multiply the top by 14. So I get 14. Now, if you're not sure if this is working, just think, well, if I reduce 21 over 42, will that give me 1/2? Yes. Now, 14 over 42 is a little bit more difficult, but is that 1/3 if I reduce it? Yep. So, what times 7 is 42? 6. But then I have to multiply the top and the bottom by that. So that gives me my 42. That would give me a 6. What do I do with the stuff in the denominator? Nothing. That's going to stay. What about the numerator? Add, add, add. So that's 20 plus 21 is, did that really just happen? 20, oh, okay, 20 plus 21 is 41. There's my answer. I thought it was 42 over 42. I made this problem up. I couldn't imagine it would equal 1, but here we go. Here's a twist, okay? Notice, this is screaming out to you. Factor me, factor me. So if you don't see that, these problems are going to be nightmarish. So we're going to rewrite this as x plus 3 all over x minus 1, x plus 1. I'm going to give myself a lot of space here, plus 2 over, that's another trinomial that we've been dealing with, so you factor it. X minus 2, x minus 1. All right. Why did I build this problem prior to this problem? Notice we had a 7, a 3, and a 2. Different, different, different. Look at x minus 1, and I have an x minus 1. So those are common in each of those denominators. So I'm going to take one in each. Okay? So we're looking for common denominators, and they share that in common. Now we have an x plus 1, and this one doesn't have 1. Remember, these are all different, 7, 3, 2. So we had to go 7 times 3 times 2. Anything different, we need to include in our denominator. So my x plus 1, I'm going to bring that along, but this one needs it also. And then we've got this x minus 2. So that has to be included in my denominator. This kind of represents 7 times 3 times 2. But then I also need it, I'll just put it over here, x minus 2. Okay? Hope that doesn't throw you, but they're the same thing. Now you got to ask yourself the question, what do I need to multiply this denominator by to get me that? Well, that would be x minus 2. But then I need to do the same thing to the top. Now I'm going to put parentheses around this because voila, we have a FOIL problem. So x times x is x squared, 3x, negative 2x, minus 6. I'm going to add these like terms and go x squared plus x minus 6. All right, now don't worry about factoring this. All right, we're trying to add fractions. So our only goal is to find common denominators, find out what the resulting numerators are, and then add the stuff in the numerator. So I'm going to ask the same question over here. What do I got to multiply that by to get this? Well, the only thing missing is my x plus 1, so I have to add that to the bottom, and that would just transfer here. You don't need to multiply all this out. And then you do the same thing with the top. Distribute 2x plus 2. So I'm running out of space, so I will put my answer over here somewhere. I got common denominators, x minus 2, x minus 1, x plus 1. Now I'm going to add the numerators. You can only add like terms. So I got an x squared all by itself. I got an x and a 2x, giving me 3x. Negative 6 plus 2 is negative 4. Like I said in the previous example, you think you're done. You got to take one more second and say, okay, think of it this way. If you left your answer as 2/4 and you had a really tough professor or math teacher, they might go, oh, no, you didn't. Half off, or if it really means wrong, because you're always looking to reduce fractions. This is way more complex than this, but it's the same thing. Because now we look at this trinomial and we're like, wait a minute, that can actually factor into 2 factors of negative 4 that add up to 3 are going to be plus 4 and minus 1. Now that's all over this denominator, x minus 2, x minus 1, x plus 1. Remember the old lesson, factor, factor, hector, hector? All of a sudden it's coming back, because now we can take out this x minus 1 in the top and the bottom, and this is what we're left with. X plus 4 all over x minus 2, x plus 1. That would be my final answer. You can see there's different levels of difficulty. This is a tough one. A couple more sample problems, we'll call her good.